Okay, I think we are in this, but okay. So first of all, good morning. And let me introduce myself. My name is Pete Nicely, and I'm the one responsible for guiding you through this course. So let me first take roll, and then we can get started with what I plan to do today. Today is the 20th. Okay, so answer your names, please. And if I happen to mispronounce it, your name that is, please forgive me. Okay. Amo or Amo?
Here.
Okay. Bassi or Basie, I'm not sure. Bassi? Oh, he's okay. Zoom. Bingy?
Here.
Is it Bolin or Bolin? Bolin? Caudill? Chestnut?
Here.
Cochran?
Here.
Oh,
Oh,
Cochran.
here.
Is it Cowood? Dennis? Is it Cute or Gute? Okay. Erlandson?
Here.
Gonzalez? Kennedy?
Here.
Lamb? Leavitt?
Here.
Leonard?
Here.
Mayor?
Here.
Manset?
Here.
Edina?
Here.
Oh, okay. Yeah, I should keep on checking on screen. Reeves?
Here.
Richardson?
Here. Here.
Oh, I see you, okay. Simpkins? Sleeper?
Here.
Paul?
Here.
Is it Swistat?
Here.
Barona?
Here.
And Ward?
Here.
Okay, very good. All right, so as I said before, my name is Pete Nicely, and I'll be the one responsible for guiding you through this course, which is Introductory Chemistry, of course. And I look at Introductory Chemistry as basically high school chemistry compressed into one semester, right? And this course, of course, is the prerequisite to the freshman chemistry course, General Chemistry 1, lecture and lab. So if you have to do that course to get whatever major you're aiming for, then you're definitely in the right place in terms of being prepared for that. So the plan that I have for today is that I'm going to go through the syllabus so that we're all on the same page in terms of what you should expect from this course and what I expect from you, all right? And then I'm going to show you where things are located in Canvas in terms of the materials I've posted and published and all that good stuff, all right? So, and of course, if you have any questions along the way, please feel free to ask. That's what I'm here for. All right, so let's talk about, make sure this is working. Okay, so let's talk about the syllabus. On the very first page, you'll see some general course information, the course title, the course number and section, and the credit hours, my name, and my office location. So here I'm located in room 208E. Now, I just found out last Friday that on the Ocala campus, because I'm between the two campuses, by the way, right? I have classes over there and I have classes here, right? I'm basically here on Tuesdays and Thursdays. I'm over there on Mondays and Wednesdays. I just found out Friday that I'll be moving from this room right here. So as soon as I get the new location, I'm going to change the syllabus to reflect that particular change. My office hours are provided here. And I think there's a change in this as well. I'll let you know, and I'll make the appropriate change as well, all right? And then the meeting time, of course, is Tuesdays 11 to 12:15 p.m. And the course location, of course, is right here. And these are the meeting dates my extension, and my regular college email address. But let me just say, as far as that is concerned, I would very much prefer, if you need to contact me via email, I would very much prefer that you do so through the Canvas system, right? The main reason why, and to this day, I don't understand why this is the case. If you try to send me an email from your Patreon account, for some reason it goes into my junk folder, right? Obviously, I don't check that folder very much. So if you need to send me an email, make sure you do it through the Canvas system. Another advantage of the Canvas system is that when you send me an email, I can see which of my courses you're enrolled in, and I can respond appropriately, all right? So basically, and typically, I respond to emails within 24 hours, all right? Excepting weekends. Okay. I also require that each student have a Skype account, and here's a link for you to create that account, right? And this is to facilitate, communication between me and you guys, especially since during my office hours, I know that some of you may not be able to come in person. Well, that's the reason why I require my students to create a Skype account. As soon as you do that, make sure that you send me, I think they call it a Skype contact request, right? And by the way, my Skype address is shown here, keep that nicely. And if you see a Clearwater, Florida address associated with it, that's me, right? I haven't gotten around to changing that, all right? So make sure that you send me a contact request so that I can have you in my list. In your contact request, and I probably should have included it here in syllabus. Make sure you give your name, of course, and the course of mine that you're enrolled in, all right? That's important because you wouldn't believe the amount of solicitation messages I get. And I want to make sure that I distinguish between my students and everybody else, all right? And just to sweeten things a bit, there's that 10% bonus point added to your first test only after you obtain your Skype account and you send me the contact request, all right? So that's basically as far as that is concerned. Below that, you see something, a statement concerning emergency closure. If a hurricane or some disastrous event is happening, then if you're signed on to the WAVE system, you should get a telephone call, a message, or you can call these numbers here. And also, typically on the CF website, there's a banner at the top that they usually put to indicate what's happening. If the college will be closed on a particular day, when it will open up and all that good stuff, all right? So that's as far as that's concerned. And then below that, you see a brief description of the course, which includes a study of measurements, historical approach to chemistry, periodic table, gas laws, thermodynamics, chemical stoichiometry, acid bases, and oxidation reduction. And then there's an additional course description, which I'm not going to read all of it. We were told as instructors that we need to include this part here, which basically deals with being tolerant of other people's views when it comes to class discussions and so on. I can say that in this course and in pretty much all my chemistry courses, it's very rare that you have controversial views being discussed. So I don't think there's too much to worry about that. But we were told as faculty, regardless of what we're teaching, that we need to include this statement. All right, so you can read that on your own. As far as my teaching philosophy is concerned, it is my belief that the best way to learn chemistry is by engaging in problem solving exercises, right? So rote learning, the memorization, all that stuff, as far as I'm concerned, is not really important, right? I've seen situations, for example, in the past where I've had colleagues who require their students to memorize, for example, all the polyatomic ions and monatomic ions and so on. That's not I don't do things that way, let's put it that way, all right? So my emphasis actually is basically you learning the concepts so that when you're encountering a problem, then you can basically show the steps to solving the problem and get to the right answer, right? So in engaging in that sort of exercise, you develop critical thinking skills and independent learning skills, all right, which will benefit you not only for this course, but in the future as well. The goal of this course is to prepare you for the next level, as I said before, the general chemistry courses, general chemistry 1 and 2, right? And it says here, those needing a less rigorous course, let's say you're not a science major, then there are other options as well. There's CHM 1032C and CHM 1020, which I'm teaching at the Ocala campus. And then the prerequisite for this course is this course, the math course with a grade of C or better, or equivalent, or with my permission. And the textbook that is required is Introductory Chemistry, which is this one right here. This is actually the instructor's edition, so this looks a bit different, but basically it's this textbook that you're required to use. 9th edition, but even early editions can work as well, all right? Now, there's another book which I forgot to bring, I think it's in my office at the Ocala campus, called A Basic Math Approach to Concepts of Chemistry. Now, this book is not required, but I would highly recommend that you get it. It's kind of like a workbook, it's not really a textbook, all right? So basically, and I wish I brought a copy of it here so that you can look at it. But basically, the way it works is that they will, if you go into a particular chapter, the first part of the chapter will briefly go over the concepts, and then they will show a few work examples, and then the rest of the chapter is basically problems for you to work on, right? So, you know, as I said before, this is the best way to learn chemistry, to basically engage in problem solving exercises. And I would highly recommend that you get this book in order to gain skills in that area, all right? And I realize I made a mistake here. Oh, I repeated something here, okay. Oh, I basically repeated what I just said here, okay, so I'll make sure I change that as well. I'm going to skip the student learning outcomes. You can read it on your own. Basically, it's just a summary of what you should be gaining from this course in terms of, you know, as I said before, problem solving skills and so on. Let me get to the assessment. So basically, you'll be given 3 exams worth 100 points, and they'll be given at the dates below. And let me just say, and I probably should have included this in the syllabus as well, these exams will be done in the testing center, right? And you can choose to do it at any of the testing centers. So if you find it more convenient to do it at the Levy or the Ocala campus, that's fine, all right? The lowest grade will be dropped. Oh, and by the way, going back to the testing center, you'll notice it says here that the tentative test dates will be the week of, right? So basically what I'm going to do is submit the test at the testing center on a particular day, usually the Sunday evening. And then you have the week from Monday to Friday of that week to go to the testing center and do the test, right? And my understanding right now is that the way the testing center works in terms of allowing you to come to do the exam is that you have to go to their website and set up an appointment, right? And I think there are some rules saying that, for example, you cannot schedule to do the test like 1 hour before closing or something like that. I don't remember exactly what it was, but I'm quite sure they would make it clear when you go to the website to schedule the test, right? The lowest grade will be dropped. Absent is of course 0. And also you'll be given assignments during the course, right? All work must be done in ink, no pencils. And these are the tentative test date and the final exam date as well as given. And I forgot to put the time, but I think it's the same time as the regular class time on that day. So I'll confirm that and get back to you on that. This here represents a breakdown as to how each type of assessment contributes to your final grade. So the regular semester exams will be 50%, and this here should be assignments, not quizzes, which would go at 20%, and the final exam will be 30%. And just to show you how your final grade will be calculated, so here we have a hypothetical student. This student gets an average of 85% for the exams, 82% for the assignments, and 90% for the final exam. And because the exams, the regular semester exams are worth 50%, whatever average you get, you're going to multiply by 0.5, and that will represent 42.5 out of a maximum of 50%. As far as assignments are concerned, because it's worth 20%, you're going to multiply 0.2 by whatever the student earned to get 16.4 out of a maximum of 20. And then the final exam, which is worth 30%, because of that, I'm going to multiply 0.3 by whatever the student earned on final, and that would represent 27.0 out of a maximum of 30%. And then I'll add up the 16.4 plus the 42.5 plus the 27, and that gives 85.9, which according to the grading system established by the college, that would be equal to a B, right? 85.9 would be within the B range, all right? So basically the setup in Canvas takes into account all these different weightings, as I mentioned before. So basically, as the semester progresses, as you turn in assignments or you do your exams, I'll be entering the scores in Canvas, and you can, of course, see what your average would be in real time, and you can basically track your progress in that way. Okay, so as I said before, this is the letter grade system that the college has established, and the key thing here that you need to keep in mind is that the grade actually represents something about what you have gained from the course. So for example, it says here that the grade of A in this course will imply that a student has mastered the full range of topics covered in the lectures and can very successfully apply these to solve the problems presented. The student can derive important practices that lead to the best solutions and make particularly insightful contributions to that discussion, right? So that's basically what A means. And then you have some descriptions about the other letter grades, B, C, and so on. Let me just say something about the I grade, because in the past, I've had issues with students not understanding what the I represents in terms of, what you have done in the course. The I grade, I stands for incomplete. It basically represents the fact that you have not completed the coursework. Now, in order for you to get I grade, there must be some legitimate reason why you're not able to complete the coursework. So, for example, if you have some illness in the family or your own illness or something catastrophic happening to you personally, and because of those events, you're not able to complete the coursework, then the way this works is that you'd have to furnish me with evidence for the reason why you're not able to complete the coursework. And then I would pass it on to the Associate Vice President of Arts and Sciences, along with other documentation. And in that documentation, there will be a plan in terms of what you need to do in order to complete the coursework, and it should be a scheduled plan. And there's a deadline by which all of that should be completed by sometime early in the next semester. I don't remember exactly what date or month that is, all right? So that's basically how that works. Now, the reason I'm going through all this is because in the past, I've had students come to me, and this typically happens close to the end of the semester, and they will say to me that, Dr. Nicely, my grade is not shaping up into what I want it to be. So if you could give me an I grade so that I can do some more extra credit work so that I can have an improvement in my overall average. That is not the purpose of the I grade, all right? As I said before, the I grade is only given under circumstances where you're not able to complete the coursework because of some personal issue, all right? So I just thought I should talk about that so that there's no misunderstanding when it comes to giving the I grade. Okay, examination assignments. Exams will cover materials from lectures, texts, and assignments, and these exams will be primarily problem-oriented. As I said before, best way to learn chemistry is to engage in problem-solving exercises. Assignments will be posted in Canvas and are due on the day specified. These must be completed by hand and either submitted in person or by Canvas. And I think right now I'm going to change that. I'm just going to say that pretty much all your assignments should be submitted by Canvas, all right? Just to make sure that I can properly track your assignments. Now, in that vein, what you need to make sure is that if you're going to upload your assignment in Canvas, make sure you do so via or using, make sure you save your document as a PDF file and upload it as such, right? In the past, I've had difficulty downloading, for example, from Canvas, downloading documents that are in the PNG format, and what's the name of the other one? What's the name of another format?
X.
I'm sorry?
The docx, like Microsoft Word, docx.
Well, I don't know about that one, but anyway, PDF works best. I've had very little issues downloading. Oh, JPEG, that's the other one I was trying to do. So please do not save it and upload it as JPEG or PNG. PDF works fine. I've had very little issues in terms of downloading PDF documents. So make sure that you save and submit your assignments as a PDF document. As far as your assessments are concerned, as I said before, you'll be doing it at a testing center. Any one of them is fine. And when you go there, you have to, of course, show your ID to verify that you're the person. Okay, and this is the schedule of basically what you'll be doing this semester. And I'm going to do my best to stick to this schedule. But of course, as you all know, life happens. So therefore, it may be necessary for me to make changes to this schedule, and I'll try to be fair as far as that is concerned. Okay, so these are some things I have to read out to you guys. The College of Central Florida is committed to helping you succeed and achieve your academic, personal, and career goals. There are a wide range of resources and support services available to you. When you connect to the resources and support systems on campus early, you are much more likely to be successful in your classes and complete the path more quickly. One example is through what is called the ESP Early Support Program, where you may receive an email indicating your professor or advisor is reaching out directly to help you connect the support services. So for example, let's say in this class, I noticed that one or two of you guys are not coming to class or not turning in assignments, etc. Then what I will do in that situation is send a, well, not send, but, well, complete an electronic form for you, provided by the ESP folks, and then they will reach out to you and try to connect you to services that may help you if you're, facing certain issues. So as stated here, if you need tutoring or financial support or psychological support services or disability services, then they'll point you in that direction. All right. And it says also that you can also reach out to these services as well. So that's basically that. As far as academic integrity is concerned, cheating and or plagiarism will not be tolerated and may result in an FF for the course, as well as disciplinary action under the Code of Student Conduct. A student will be referred to the academic integrity seminar if you are found violating the college's rule concerning cheating and or plagiarism, right? So basically that FF grade is stating that you have failed the course for those reasons. That FF grade, however, can be removed, as I said before, if you attend the seminar, the academic integrity seminar. It's a 2-hour seminar. There's a charge associated with it, which I don't know what it is right now. And basically, if you complete that seminar and then complete the rest of the coursework, then you're going to get the grade that you would have earned as a result. If you don't complete the seminar, then that FF grade will remain on your transcript. All right. If you're a student with a disability of any kind, it's important that you go immediately to the Office of Access Services. And the way this works is that you go there, they determine the type of accommodation that you're going to need, and then they will send me a document which basically indicates the accommodation that I need to provide for you. All right. So you need to do that as soon as possible if you have not done that before. So the point person, as far as that is concerned, is this lady, Cindy Frenda, right? And her phone number, office location, and website is provided. All right. Equal access, equal opportunity. The College of Central Florida does not discriminate against any person on the basis of race, color, ethnicity, religion, gender, age, marital status, national origin, genetic information, or disability status in its programs, activities, and employment. For inquiries regarding the non-discrimination policies, please contact Karen W. Smith, and her location, extension, and email address are provided. Class with decorum, disruptive behavior will not be tolerated. Disruptive students will be asked to leave the classroom. And if the disruptive behavior continues, then you may be withdrawn from the course and face further action under the Code of Student Conduct. And then we have what is called the Student Assistance Program, which is a service provided by the college. And in my opinion, it's a worthwhile investment in the students here. If you have any personal problems that basically interferes with your school life, personal life, work life, whatever, then you can have access to a therapist through an HMO known as Daycare Life Management. And the way this works is that there's a toll-free number, scroll down here. This is the toll-free number right here. If you call this toll-free number between 8:30 to 5 p.m. Monday through Friday, then that will put you in direct contact with a therapist, and he or she will be able to help you with whatever issues you're dealing with. If you call outside of that time frame, then what will happen is that the therapist on call will be paged, and then he or she will immediately call you back, and again, will be able to help you with whatever problems you're facing. So I would recommend, if you need this help, that you take advantage of it. All right. Withdrawal. Yes, I need to say something about withdrawal, because again, in the past, I've had issues with students who, may attend class for the first 2, 3, 4 weeks, and then he or she just disappears, right? And this has happened before. And I remember the first time it happened, at the end of the semester, that student's name was still in the system as being enrolled in the class. And I remember I asked about it because I was wondering if something happened to the student. And I went around and asked my colleagues and they said that, look, all you can do is put the grade that the student earned. And unfortunately, that's what I did. So I'm mentioning that to say that, look, if you have to leave or withdraw from class, and let me just say, I hope nobody withdraws. I hope everybody stays. I hope everybody work hard and succeed in this course. But I understand again, life happens, personal issues may arise, and therefore you may find it necessary to withdraw from class. If that's the case, then make sure that you complete all the documents, some of which has to be signed by yours truly, so that you won't suffer a hit on your GPA at the end of the semester. All right, so please make sure you do that if you have to withdraw from the course. And then below you see some important dates. And as far as I can see, today's Tuesday, right? So I don't see any dates here in terms of holidays that would affect us. So we won't get a break as far as this class is concerned, based on the calendar I'm looking at right here. Just check the picture because this is Monday. This is the Monday. Thanksgiving is Wednesday, Sunday, and professional development days are Thursday. So, yeah. So basically, this class will not be affected by any holidays or days off. Okay. The college reserves the right to evaluate individual cases of non-attendance. Students should be alerted to the fact that 1, withdrawals do not count in the CFGPA, but may not be viewed favorably at the university level or for financial aid. 2, a withdrawal counts as an attempt on the forgiveness/withdrawal policy. And of course, repeat policy. 3, there are increased costs to take the course on the third attempt. And if I'm not mistaken, if you have to take the course a third time, then you pay out-of-state tuition for that course. And then 4, there may be a reason a withdrawal request may be denied. And if you have any further questions concerning that, you may see the college's withdrawal procedures. Equity statement, and again, this is something I have to read out to you guys. The College of Central Florida offers equal access to opportunity in employment, admissions, and educational activities. The college will not discriminate on the basis of race, color, ethnicity, religion, gender, pregnancy, age, marital status, national origin, genetic information, sexual orientation, gender identity, veteran status, or disability status in its employment practices or in the admission and treatment of students. Recognizing that sexual harassment constitutes a discrimination on the basis of gender and violates this policy statement, the college will not tolerate such conduct. And let me just say here that I've been teaching here for a couple of years, and I can tell you, based on my observations, that the college takes very seriously any complaint concerning sexual harassment. All right. In fact, every college employee, faculty and otherwise, are known as mandatory reporters. And what does that mean? That means that, let's say if you come to me and let me know that you have been sexually harassed by anybody here, then I'm obligated to report it to the person in charge, who is Dr. Miriam Bailey. All right. So that is something that you guys need to be aware of. You can't just go to a professor or go to somebody and tell them, well, this person harassed me sexually, and then expect them not to say anything, because we are obligated to report it to Dr. Begley. Or you can go directly to Dr. Begley. She's a nice lady. I know her personally. I work with her on certain issues, and she is very accommodating in terms of basically guiding you through this process when it comes to these issues. Hopefully, of course, you don't have to go through all of that, but you know that things like these happen pretty much everywhere. All right, unfortunately. All right, so as far as the point person, when it comes to this particular issue, Dr. Miriam Begley, she has a title of Director of Compliance and Planning, and she was also the Title IX Coordinator. Title IX is a federal law that deals with discrimination, and there's a section of it which deals with sexual harassment. So she is the person who knows all about that when it comes to sexual harassment and discrimination. Her location is provided, as well as her phone number and her email address. Okay, and then we get to the last page. I like to call this my CYA document. You all know what CYA stands for, right? Well, he knows, right? You all know what CYA stands for, right? She knows. Okay. For the rest of you, CYA stands for cover your ass, well, cover your ass, but in this case, covering my ass, all right? Make sure you complete this document, the very last page. Basically, by completing it and signing it, you're basically saying that you're ready syllabus, understood the terms, you know what to expect, and know what is expected of you and all that good stuff. And make sure you turn it into me before you leave here today, all right? Any questions concerning what I've gone through with respect to the syllabus? Any questions? Any questions? Any questions?
For
Yes, sir.
the testing,
Mhm.
how do we, is that through the CF website? The
Yes, I don't remember exactly where, first, because I don't have to do that test here, but, let me see here. Thank you. But I know there's a website that you'd have to go to, so let me see, where would I go? Testing and assessment. And, okay, so this is it. You know, you schedule your test. There are some instructions here in terms of the procedures and so on. So that's basically where you go to do that. Any other questions? How about you guys? Oh, I'm sorry. Yes, go ahead.
Where do you get the book?
Should be available at the bookstore. All right. Unfortunately, we don't have a bookstore here on this campus. It's closed a couple of years ago. I don't know why they did that, but the bookstore at the Ocala campus should be there. If it's not there, let me know. All right. How about you guys out there in Zoom? Any questions out there? Any questions?
All
If
good.
not, then, oh. Did I hear what?
Yeah, I was just saying all good.
I'm sorry.
Everything's good, no questions.
So let me show you in Zoom where everything is located. So if you go to the, not Zoom, I'm sorry, Canvas. If you go to the Canvas page, you will see, the home page will be this right here. So I've included, in the Canvas page, the same syllabus that we went through, that's right here. Again, I'm going to make some changes in terms of my room location and other errors that I've, just discovered in my syllabus. So I'm going to try to do that this evening and upload it, so that you have it, the new version of the syllabus. Of course, announcements, you know, from time to time, I'll post announcements reminding you of deadlines, or if I cannot make it to class at a particular time, or if instead of, because this has happened the last semester, one time where, I could not make it here, so I held class fully on Zoom on that particular day, right? But, so that's basically, the announcement sections, the assignments. I think this is where, I'll post the drop boxes for the assignments. I'm going to clear that up. And of course, your grades is accessible here. Most of what you're going to need for this course will be located under the files link. So if you click on the files link, there are certain folders that are published so that you can see the syllabus, the same syllabus that I've posted here is located here. So that's the syllabus. Again, I'm going to make the changes and upload the revised version and tables, right? Now, as I said before, you know, I'm not a big fan of requiring students to memorize, you know, like ions and so on. So that's why I provide these tables. We'll be using these tables pretty much throughout the whole semester for reference purposes, right? So let me just show you what I'm talking about here. So let me make this full screen. So this is the periodic table right here. This is one version of the periodic table. Another version is right here. And I've also included a list of all the elements in alphabetical order. And this is basically a table with common ions. In fact, I have 3 pages, if I'm not mistaken. Yes, that's the second one. And that's the third one. These are all common ions, right? You don't have to memorize these, but you need to know how to use them, right? So that's the reason why I'm making them available to you guys. And then we have conversion factors. This will become important later on when we're converting from one unit to another, right? Again, I don't expect you guys to memorize these numbers. You can just refer to them because you'll have the tables available to you. And by the way, these tables will be available to you in your test. So when you go to the testing center, not only will you be provided with the test itself, but you'll be provided with this table as well, all right? And also, I typically require that they provide a sheet of scratch paper, right? So you have that to work with as well, all right? What else is here? Some equations, right? So even some equations that you don't need to memorize, all right? Some more equations here. And then we have, let me make this right side up. We have some prefixes. We're going to talk about this in more detail in this course, where according to the metric system, you can use the base units along with certain prefixes to express, some measured values, quantitative values, larger and smaller, all right? So that will be provided for you. Again, you don't need to memorize these. And then you have this table, which is basically what we call a solubility table, which will become important later on as well. I think about chapter 4. And then the last page gives you electronegativity values. Again, that will be important later on in I think chapter 9. All right, so you'll have access to this, as I said before. You'll be using this pretty much throughout this course whenever we're doing problems in class. All right. What else is here? Here. I will also provide the assignments, which will be located here, right? So let me just open this up just to show you. I haven't published yet, but basically these are the assignments. I may make some changes. That's the reason why I've not published them yet, but these are the assignments that you'll be doing. And basically each chapter has its own assignment. So it will be an assignment per chapter, right? And let me just explain. So typically, well, in this particular course, it's a hybrid course. So basically you'll be watching videos, and I'm going to show you where the videos are located. These are the video lectures that you'll be watching, right? And then, like for example, for next week, you'll be watching the videos for chapter 2, right? And then next week, during class time, what you'll be engaging in is basically problems as it relates to chapter 2. Typically, what I will do first, however, is to ask you if you have any questions concerning the videos, right? So if you may watch a video, you may encounter something that you don't understand or is not clear to you, then class time would be the time for you to ask those questions. Or you can even contact me during my office hours and ask me those questions as well, right? And then after that, then we get into the problem solving exercises, right? So this is basically where those assignments are located. Let me just see here if there's anything else. As I said before, I'll give you your test in the testing center. After grading them, then I'll get them back to you, and I will post the answer keys to the test. Oh, I'm sorry, I'm jumping the gun a bit. So after you have done the assignments and I've graded them, I will send the assignments back to you, and I will also post the assignment keys here in this folder, right? So therefore you can go there, look at the answer keys, compare to what you have in your test, your graded test. If there are discrepancies or if you think I've, graded something in error, then please feel free to come and contact me. So basically, after doing that, then you're going to get your next test. So let's say, for example, you have completed 3 or 4 assignments. Usually it's about that, right? Then your upcoming test will be based on those 3 or 4 assignments, right? And you're going to do the test in the testing center. I'm going to grade it. I'm going to also provide the answer keys after sending the test back to you. And the test answer keys will be located in this folder right here, right? So, or this folder, I'm not sure which one, but I'll provide it, all right? So that's basically how I'm going to run this course, right? We do the lecture, or you watch the lectures, we do the assignments in class, I grade the assignments, I give you back your graded assignments, I post the answer keys of the assignments, and then you'll get your next test, and then I'll grade those tests, give you back your graded test, post the answer keys in your Canvas test key folder, and basically that's it in terms of how this course will be conducted to the end of the semester. Okay, as promised, videos of the video lectures covering the different topics here. So basically in this folder here, and is where you're going to find your videos. So I'm looking for the right. Okay, so what I'm going to do today is basically talk about the first chapter, which is a very short chapter. But I'm going to publish the video for that anyway, just in case you need to, review that. And I'm also going to publish the videos for chapter 2. So this is what you need to watch. These are the videos that you need to watch in order to prepare for class next week, Tuesday, all right? So now that I've published them, you have access to them, you can watch them. And again, if you have any questions concerning these videos, please feel free to contact me during office hours, or we can discuss it in class, all right? And that's basically the standing arrangement every week, right? So as soon as we complete one chapter, I'm going to publish the other chapter for you to watch for the next week and so on, all right? So that's where these are located. Let me unpublish this to avoid confusion. And I think that's it. I don't think there's anything else in the Canvas shell that I can talk about. Unless there are any questions. Any questions concerning what I've just discussed with respect to the Canvas? Any questions? Any questions? Any questions out there in Zoom?
No, sir.
All right. Okay, so with that said, we're going to get into chapter 1, which is a very short chapter. Oh, by the way, I forgot to mention PowerPoints. So basically, the videos will cover the PowerPoints, and like the one that I'm going to cover today. Those PowerPoints are located here in lecture notes. Let me publish that right now. Right? So if you go there, you're going to see the PowerPoints for all the chapters, and I'm going to open up the PowerPoint for chapter 1. So we're going to now delve into the wonderful world of chemistry. Are you excited? Oh, such an overwhelming response. Maybe you guys out there in Zoom are more excited than these guys here, hopefully. All right, so let's talk about chemistry. What is chemistry all about? Well, chemistry, that's basically the definition of chemistry. It's that area in science which deals with the composition, structure, properties, and reactions of matter. Later on, we're going to talk about what we mean by this term matter, and especially of atomic and molecular systems. Okay, so matter. What is matter? Matter is anything that has mass and volume, right? So basically anything material, all right? And that's basically what we're interested in when it comes to this particular discipline of chemistry. Now, in chemistry, we're concerned with several aspects of matter. The first one being mentioned here is the composition. So when we're talking about the composition, we're talking about the makeup. Okay, so we're talking about the makeup, right? Basically, the stuff, the different materials that make up the particular object, right? We're also concerned with the structure, right? In other words, we're concerned with how the smallest units, atoms, ions, and so on, how they're arranged with respect to each other. They're connected, and especially when it comes to more advanced chemistry, organic chemistry, and so on, we're concerned with the three-dimensional arrangement of the atoms and ions within the structure of the compound or substance. The next thing we are concerned with in chemistry are what are known as properties. So when we talk about properties in chemistry, we're talking about those defining characteristics, right? And we're going to delve into that in more detail at a later chapter. But things like color, things like boiling points, melting points, hardness, softness, taste, even though I would strongly recommend that you don't practice tasting stuff in the lab, and stuff like that, right? So basically those observable characteristics, which is unique to a particular substance. And then finally, we are interested in the type of reactions, right, that these substances undergo. So that's basically what chemistry is all about. And they're all interrelated, right? So structure is related to composition. Composition basically tells you the makeup, but the structure tells you how the different individual units that make up the substance are connected to each other. The properties are related to both structure and composition. And reactions is actually a subset of properties, to be perfectly honest, all right? So that's basically what chemistry is all about. So I like to say, and I love this diagram right here because, and of course I'm completely biased, I like to say that the most important scientific discipline is chemistry, all right? And, you know, this is not an exaggeration because chemistry is basically involved in different, well, a lot of different scientific fields and also non-scientific areas as well, right? So chemistry, of course, is related to physics, related to engineering, related to biology, forensics, computational chemistry, medicine, toxicology, and all that. Chemistry is involved in all these fields, right? So for example, if you're a biology major, you have to do some chemistry, up to and including, if I'm not mistaken, organic chemistry, right? So basically chemistry is the most important discipline there is in science. And even my own colleagues in biology would admit that as well. Admittedly, grudgingly, but they will admit it, all right? But there are also some other areas as well where chemistry is involved. For example, in business, in law, and all that good stuff, all right? In fact, I've known persons who have graduated with chemistry degrees and they end up doing law. There's an area of law known as patent law, right? Where if people come up with inventions, then they run it by a patent lawyer and he or she would scrutinize it to see if it's up to scratch so that they can submit it to the federal government so that that person who created the invention will get full credit for it and nobody can use it for their own benefit, all right? So that's basically summarizes the importance of chemistry in our world, all right? Now I want to take a bit of a detour and talk about the scientific method, which of course applies not only to the science of chemistry, but applies to pretty much every other scientific endeavor, right? So the scientific method is basically the process that is used by scientists to explain what is observed in nature. And there are several steps involved in the scientific method, and we're going to go through them so that you get a feel for what is involved in the scientific method. And the first step is that you make an observation by defining the problem and recognizing it and stating it clearly, right? So that's the very first step in this process of the scientific method, all right? The second step is that you come up with a tentative explanation. And this explanation is not just something that you, well, you do make it up, but it's not something that is out of reason. It must be a reasonable explanation for what is observed in the first step. So we call this tentative explanation the hypothesis, all right? And then the next step is that we have to now decide the best way to test the hypothesis, right? And in the natural sciences, the way we test the hypothesis is that we design an experiment and then we perform the experiment to test the hypothesis, all right? And this is where most of the hard work of the scientists is involved, all right? Now, more often than not, what will happen is that after you have done your preliminary experimentation on your hypothesis, you look at your data to see if your data or your observations fall in line with your original hypothesis. Initially, in the vast majority of cases, that will not be the case, all right? So what does that mean? That means that you have to go back and come up with a new experiment. Well, actually, you have to come up with a new hypothesis to explain what was observed in the first step. So basically, you come up with a new hypothesis, or you make some modification to the original hypothesis, and then you carry out testing on that hypothesis again to see whether or not your data will fall in line with what your new hypothesis is predicting. And that process is repeated over and over again until you get some harmony between your resulting data and your refined hypothesis, right? So when you get to that point, that observation is basically what we call a scientific law, right? Usually it's a mathematical description, but not always, right? And this is basically a statement of what you observe, which is always going to happen without any exception. After that, you put forward a theory. Now, a theory is basically an explanation, but unlike the hypothesis, the theory is backed by the weight of the evidence obtained by repeated experimentation and of your generated hypothesis. That's what I mean, right? So basically, the difference between the theory and the hypothesis, and we're going to see that later on, a side-by-side comparison. The difference between a theory and a hypothesis is that the theory is backed by the weight of evidence obtained by repeated experimentation, while the hypothesis is basically an explanation which is not yet tested, and it forms the basis for repeated experimentation, which will lead you to the theory, all right? Now, so this here is a flow chart, which basically shows you what we just discussed, right? But there's another aspect which I didn't discuss, which I'll talk about shortly. But let's go through the flow chart. Your observations is what you did in the first step. This is what you basically detect that through your senses, what you see, what you hear, etc. Right? Based on your observations, you're going to come up with a hypothesis to test, well, to see whether or not, well, it's basically a tentative explanation, proposal, and then you do your experimentation to test the hypothesis, right? As I said before, initially your data will not fall in line with the hypothesis, so you have to go back here. You have to either refine the hypothesis or come up with a new one, and then you test it again by doing other experimentation. And this process repeated over and over again until you get some harmony between your experimental data and your hypothesis. When that happens, that hypothesis becomes a theory, right? Remember now, the theory is basically an explanation that is supported by the weight of the evidence, the data, the observations that you would have obtained from repeated experimentation at this stage right here, right? Now, one thing I did mention, which is also a very important step in the scientific method, is that when you end up with your theory, that does not necessarily mean that's the end of the story, all right? In fact, somewhere on this planet, you might have a scientist tinkering in the lab, testing the theory that was basically developed by somebody else, right? So there's further experimentation that can be done with the theory. And what you'll find is that in some cases, I'm going to mention one example shortly. In some cases, people have done experiments on theories that have been well accepted by the scientific community and come up with evidence that basically contradicts the theory. And when that happens, what that means is that you have to come back up here, right? In other words, you have to come, well, actually up here, you have to basically, well, here, you have to basically, again, come up with a new hypothesis, experimentation, all the way down the line, so as to get a better theory to explain what was observed, right? So basically what this means is that you might have a theory that is well established, well accepted by the scientific community, but if evidence is developed so as to contradict that theory, then basically we have to discard that theory as being not applicable anymore, right? So what this shows you that the scientific method has this basic self-correcting procedure, which allows for correction when we know that a particular established theory doesn't work, right? If the evidence comes up which shows that, then basically we have to discard it, all right? Okay, so let me give an example of how this works. So let me do this. I'm going to do this pretty slide. Now, and this is my favorite example of how the scientific method works. Now, back in the day, and I don't remember what year it was, but it was a long time ago. There was a theory that existed that was accepted by chemists known as vitalistic theory. All right? And basically, what this theory says is that there are natural compounds that exist in the universe, right? And, you know, these compounds are found in the tissues of plants and animals, right? And according to this theory, human beings like yourself, cannot make these substances in the lab, right? That was a belief back then. The belief was that there's something out there in nature known as a vitalistic force, which is necessary for the manufacture of these compounds in the tissues of plants and animals, right? So that was the theory that was believed for quite a while, and then a guy by the name of Frederick Wohler was from Sweden, so you have two dots over the board right here, right? And he was trying to make this compound. The name of this compound was ammonium cyanide, right? So he did a series of several reactions leading to the formation of the compound in an aqueous solution, right? Now, This compound is ionic, by the way, and typically, if you have an ionic compound in an aqueous solution, right? In order to isolate the compound itself, all you have to do is heat the solution, evaporate the water, and then the compound should be isolated that way, right? And that's exactly what he did, right? He heated the compound, but what happened instead is that there's a transformation. This compound was converted to this compound. And the name of this compound is urea. Right? Now, can anybody tell me where in nature you will find this compound? Yes, sir.
Find it in urine.
In the urine of mammals, cows, goats, human beings, and so on. And this was the first recorded instance of a compound that exists in nature that was actually produced in the lab. And this was totally by accident. He didn't plan to do this, right? Basically, as I said before, what he wanted to do was isolate the solid form of this. And it turns out that when you heat it in a solution, you're going to end up with urea, right? And as a result of his discovery, that signaled the end of the belief in this vitalistic theory, and it opened up a new branch of chemistry known as organic chemistry. Right? So this is just one example, and there are several others I can point to as examples of the scientific method working, all right? In order to make new discoveries or come to a conclusion as to how things work in nature, all right? Okay, so with that said, let me move on to emphasize some definitions that we talked about earlier. Again, we need to understand the difference between what we call the hypothesis and what is called the theory. The hypothesis is a tentative explanation of what is observed, right? It forms a basis for further experimentation, while the theory is after experimentation, right? So you have done repeated experimentation, you came up, and as a result of that experimentation, you come up with an explanation. That would be the theory, right? As stated here, the theory is basically a well-established hypothesis, right? Now, it's important, of course, for you to make a distinction between hypothesis theory and what is called the scientific law, right? The scientific law is not an explanation. Firstly, let me just say that. And I've even seen high-level research scientists confuse these terms, right? Especially confusing the law and the theory, right? The theory is what explains, based on experimental data, what explains what is observed, but the law is basically a statement of a natural phenomenon to which no exceptions are known under the given conditions. And that law, as I said before, is not an explanation. So, for example, later on, I think in chapter 10, or 13, I don't remember, you'll be exposed to several laws which govern the behavior of gases. One of them would be Boyle's law, right? And Boyle's law basically states that the pressure of a gas is inversely proportional to the volume, right? That's observed every single time without exception, right? So that's an example of a law. Please note that that observation does not explain why that happened. It just says that's what happens, right? The explanation lies in the theory, and specifically as it relates to Boyle's law, there's a theory that you're going to learn about known as the kinetic molecular theory. And based on that theory, you can see how the behavior of gases at the particle level results in the observable relationship between pressure and volume as described by Boyle's law, right? So it's very important that you understand the difference between those three terms, all right? So this is a side-by-side comparison, again, comparing hypothesis to theory. So again, just to reiterate, hypothesis is a tentative explanation of facts, and then it provides a basis for further experimentation, while the theory is the explanation of what is observed, which is backed by the evidence in the form of data. So that's the difference between theory and hypothesis. Okay, now let's talk about the practical application of the scientific method. Believe it or not, I'm sure that in your everyday activities and lives and so on, you have actually employed the scientific method in solving particular problems that you may face, right? So we're going to look at this particular example. So let's say you have a CD player, right? And you want to play your favorite CD in there, and you put the CD in the CD player and the sound skips, right? So in the scientific method, that would be your observation, all right? Now, question is, what would be the possible cause of that, right? In other words, you have to come up with a hypothesis or two. So in this particular case, the hypothesis would be that the CD player is faulty. That means that there's something wrong with the CD player. So the next question is, how would you go about testing that hypothesis? Yes, ma'am. Yes, sir, sorry.
Check inside the CD player, test it with other CDs, and if it's consistently failing, then maybe you're right.
Okay, very good. So basically what you're going to do is replace the CD with another one. And in this particular case, the sound from the second CD is okay, right? So basically the working theory that you have to go with is that there's nothing wrong with the play itself, right? So what other possible hypothesis you can come up with to explain why the CD was skipping in the first place? Yes, sir.
Maybe there's something wrong with the disc itself.
Okay, very good. So something is wrong with the CD itself. It has an effect. How would you test this particular hypothesis?
If you have another CD player, you can try to see
Put that CD in another CD player and the sound still skips. So what does that tell you?
that the CD itself is wrong.
Exactly. So that's a simple example, admittedly, but it shows you basically the logical steps that are involved when it comes to the scientific method, right? And this is employed, as I said before, in pretty much all scientific fields. Okay, now there's one aspect of the scientific method which I think is very important for me to talk about. Now, I don't know what your individual career goals are, right? But I will assume that it would involve science, since you're here in this course, right? So if you plan to be a doctor, or if you plan to be an engineer, or if you plan to be a biomedical researcher, you will benefit from engaging in research and so on. But there's one aspect of the scientific method which I need to highlight for the purposes of encouraging you guys to be more honest and engaging in your integrity. So if you recall, I said that at this stage here, after you do your experimentation and you get your data, if the data does not agree with what the hypothesis suggests, then you have to go back here, right? And I mentioned that you need to come up with a new hypothesis to fit the data, all right? What you should not do, and this is very important, what you should not do is change the data to fit the hypothesis, right? That is basically the scientific malpractice, and the consequences of that is, some cases, not very pleasant, right? And I have a couple of examples. Let me scroll back to this last slide here. I have a couple of examples, real world examples of scientists who basically play fast and loose with, I can get this to open up. Okay. Well, this one is not so serious, right? Now, this lady, she is a chemist. At the time of the publication of this article, she had just won the Nobel Prize with two other scientists, two other chemists, right? She, of course, in research universities, UF, all those big schools, they publish papers, this is what, those instructors, professors do. And in her case, her research group published a paper which had some issues with it because other people were trying to replicate her experiments to get the same results, and they did not get the same results, right? And let's see if I can find the particular line right here. Right. So basically, as a result, she reported herself to the paper, the publishers of the paper that she submitted, and as a result, that paper was retracted, right? And here's the important point here when it comes to the practice of science. Reproduction is an essential part of validating scientific experiments. If an experiment is a success, one would expect to get the same results every time it is conducted. And that's not what happened in her case, right? And I think, and I could be wrong, I think this is the only instance where a particular researcher retracted their own paper, right? And one of the reasons why she had to do that was because the original notebooks that they recorded their results in, they couldn't find it. She said that she searched all up and down and couldn't find it to see whether or not they made a mistake when they were reporting their results, right? And she, the good thing about her was that she stepped forward and basically admitted that this is the case. I don't think it wasn't, of course, anything that, she intentionally or purpose did, but she said, here, it is painful to admit, but important to do so. I apologize to all. I was a bit busy when this was submitted and did not do my job well, right? And this is, a Nobel Prize winning scientist, all right? So that's one example. Another example is this one here, and in this case, the consequences were more serious. Oops, sorry. Let me see if I can copy and paste this. Oh. Now, this one actually resulted in somebody going to prison. Okay, so. Okay, so this guy was a vaccine researcher. And basically to summarize, what happened was that he was working in collaboration with some other colleagues at the University of Iowa State University. And basically what happens, and this is a common thing in those high-level research institutions. In order for them, researchers that is, in order for them to do their research, they need money. There are two possible sources of money. You have private and you have public, right? And there are drawbacks in terms of accepting money from either sources, right? If I'm not mistaken, most research at universities are funded by the public. There are some stipulations that come to that, right? So basically, 1 minute. So basically, what happened was that the person at this university who was the principal investigator, he got monies from the federal government. This other researcher was working with him, and they were looking at testing vaccines for the preventing HIV, right? Now the researcher involved here basically created some data in order to show that he had successful results in terms of the vaccine activity. I'm trying to find a line where he made the, here it is. Han was forced to resign from Iowa State in 2013 after the university concluded that he falsified the results of several vaccine experiments supported by grants from the U.S. National Institutes of Health. In some cases, Han spiked rabbit blood samples with human HIV antibodies so that the vaccine appeared to cause the animals to develop immunity to the virus, right? And then he reported that without stating that that's what he did, right? And as a result, and this is the first time, when I first saw this article, this is the first time that I know that somebody ended up in jail because of this. Because typically the punishment would be if you're found, committing such a violation or violation of that type, they would basically ban you from getting money for 5 years, 6 years, and so on, right? But in this case, from what I've read in other articles, because of the volume of money that they receive, I think there's like a threshold beyond which, if you commit something like this, then we're talking about prison time. And that's basically what happened in this case. So I'm pointing these examples out to you just to underscore the importance that whenever you're doing research, especially, that you basically be honest in your activities. Don't try to basically create data to support whatever preconceived notion that you may have of what you think the results should be. Everything should be above board, and make sure that you employ honesty and integrity in all that you do, including if you're doing labs here, right? Okay, so that's it for today. So just to remind you, chapter 2 is what we'll be discussing next week. Make sure that you watch about the videos for chapter 2, and then we're going to engage in some problem solving exercises next week. Make sure also that you turn in the last page of the syllabus, signed and completed, right? Enjoy the rest of the day. That's it. Nice. Nice.
Okay.